I want you to look at this picture on the screen, a picture that I poured all my heart, soul, and time into drawing. And before you tell me how awesome it is, the real question I have to ask you here is, which one of these slopes do you think the ball is going to roll down the fastest? Do you think it's slope A, B, C, or D? Well, some people might be thinking, well, B looks pretty steep. And others might be saying, no, D looks steeper. But how can you know for sure? How do you measure steepness? We can do that by finding the gradient. We spoke about it in our last video, but what the gradient is, it can tell us how steep something is. In other words, it's really like a ratio or a comparison of how much a line moves up to how much it moves across. For example, if I have a slope with a gradient of 2, it means that I'd move up by 2 for each unit I go across. If it has a gradient of a half or 50%, it means that each time I go up by 1, then I'd move across by 2. What do you think a gradient of 2 out of 3 means? Well, it would mean that each time I move up by 2, I go across by 3. That is why the formula for gradient is the rise over run. Now, look at this guy. Wait, no, not this one. This other one who's cycling up the hill. This is one of the steepest streets in the world, Fort Spenleck in Wales. It has a gradient of 37.5% or 3 out of 8. And anything over 16% is usually challenging to climb, so you can imagine how hard this is. I mean, if you ride bicycles, if you look at this guy's face, you know that he's struggling. So that's why the concept of the gradient is used when building roads or putting stairs in a mall, and for so much more reasons. Now, I'd say that there are two main things that I wanted to look out for, two mistakes I often see students make when working with the gradient. The first is that the gradient is always rise over run. It's never run over rise. And we keep it that way so that we don't get confused. Just like red always means stop and green always means go wherever you are. The gradient is always rise over run. The second thing is that whenever we're finding the gradient, we have to start from the same point. For example, if I'm finding the gradient of a line, I can't rise from one end and then run from the other end. If I'm rising from one point, that's the point that I'll have to run from as well. And it doesn't really matter what end we start at or what point we're starting from, but we just have to be comparing the rise and the run from the same place.